Nope. Oh, thank you. So if you guys were here last time, we had a really great time. It was fantastic. Um, Hopefully, so today I took a trip down after my first class went horribly. Bad Wi-Fi again. I have upgraded everything I could, so hopefully it'll work. I think it's been working pretty well. Anybody have questions from homework? If not, I'm going to ask some questions for you to help. Have you guys been getting into? Hopefully, you're done with chapter 7, or at least you've done a decent chunk of it. Because what's happening tonight, or tomorrow, depending on when you take it. Quiz. Yeah, there's a quiz on chapter 7.
It's due Wednesday, right?
Yeah, I made it due Wednesday morning. Yep.
Okay.
I figure that's a nice thing to do. I'm trying that out. I don't know. Trying this out this semester. This being nice thing. I don't know. Yeah, I haven't really feels icky.
What do you say, Mr. What do you say about Wednesday?
So there's a quiz that opens tonight, but it's not. It's due Wednesday morning at 8. I think I made it. So you could do it anytime from after class tonight up until Wednesday morning at 8 a.m.
Oh, okay. And
Just
we
like
have class today, tomorrow, I mean, right?
Say again, sorry.
Do we have a class tomorrow?
Of course we do. Yes.
Oh, I think I read something. There's no class.
Thursday.
Okay.
Thursday, there's no class. Yeah, Thursday, I'm actually doing.
Okay.
Yeah, there's a statewide conference thing, and I'm doing a presentation. So I'm not nervous about that at all. No, I'm not nervous about presenting at the statewide thing. So yeah, Thursday, I'm gonna be getting done with the presentation like right about 5:45. So I figured I'd just give you guys the day off. I'll probably be kind of brain fried at that point. Let me see. So no questions from homework. Okay, so let me see. Where's that one, Rio? Was it section 8.1, number 15, or 8.2? I can't remember now.
Yeah, 15.
8.1?
Yeah.
Okay. Oh, and there's the other section too. So let me correct a couple things in the book here. You can try number 15, but you don't have to do it. I want you to at least identify the shifts, but the graph, can you guys, all right, let's do this. A little review. Since nobody had any questions from chapter 7, can somebody tell me what the amplitude would be for number 15?
3.
3. All right, now somebody else tell me what the period, how would you figure out what the period is going to become? Somebody else. I can't remember now what I said. I can't remember what my own thing is. Anybody? What's the period of sine normally? Normal period for sine, somebody. The normal period for sine, someone.
2 pi.
All right. Now, so what's the normal period for cosine? Someone else. What's the normal period for cosine? Okay, all right, so let's try something else. All right, hold on. Where was this sheet? Oh. Did I make this active yet? The sheet, let's see. Yeah, how to graph trig functions, okay. See this here? All right, I didn't put, that's right. I just didn't put the plus whatever, because that's pretty easy. So this is something you have to memorize. You have to memorize this. The thing we discussed last time is transformations don't act differently. They don't care what the function is. They will always accomplish the exact same thing. So anytime I have a number out front of the function, that will vertically stretch it or compress it, depending on if it's bigger than 1 or less than 1. Always. So we just happen to call it amplitude because this is like a sound wave. And that's when we use the word amplitude, right? We use the word amplitude in relation to periodic functions very often because periodic functions are normally kind of what's called bound. So like sine and cosine are bound between -1 and 1. Is that cool? Is that all right? Okay. All right. So I know Caroline is here, and I know Rio's here, and I think Faye said something. Okay. The period. So again, the word period just talks about the actions along the x-axis. So how do I change the domain of something? So if I have a parabola, well, let's see, not a parabola. If I have any kind of function, the way I'm going to change the domain of it is going to be, the way I'm going to change how it acts in the x direction is to put a number inside. So if that number is bigger than 1, that's actually going to cut it in half. It's going to be, so if this is the original function, the new function is going to look maybe like this. It's going to be compressed. Okay, this is all old stuff. We've talked about these before. All the transformation stuff we've ever talked about does not change for sine and cosine functions. They're the same for every function. We just give them specific names for trig functions. All right, I don't know. So it really depends on how much you were paying attention before when we're talking about transformations. And can somebody tell me how much have we talked about transformations this semester? Have we talked about them just like once? We talked about a shitload. So I was trying desperately to get you ready, not just get you ready for this, but transformations are just generally important. So since the number that's multiplying by x affects the way it looks in this direction, in the x direction, that's what's going to change the period. If I smush it, if I smush this, so I make it look more like this, right? So that the period then becomes smaller. And can somebody tell me, somebody who hasn't spoken yet, can somebody tell me what the period means for a trig function, for a sine and cosine specifically? What does period mean? I'll get it started. How long it takes for the function to do what?
Repeat.
Yeah, okay, I'll accept it. So right here, it's going up from 0, and how long until it's doing that again? There. So the period, for example, of this is a sine function, period is 2 pi because that's how long it takes for one cycle. So a cycle just means it goes through all of its motions. So up through 0, and then down through 0, and then it going up through 0 again. So how long until it's going up through 0 again? Until it's gone through 2 pi. That's how long, for example, right? So it could be between any 2 points. That's what period means. Just how long in the x direction does it take for it to go through one cycle? So obviously, if I smush it, if I literally just smush it, compress it like a spring, I'm going to change the period. It's going to go faster, right? It's going to oscillate faster if I do that. And if I stretch it out, it's going to go slow. It's going to go longer. Okay. This is like a radio wave versus ultraviolet light or something. Right? This is why UV rays hurt us, because they have such small wavelengths. They interact with us. Radio waves are going through us all the time. We don't even notice. Anyway, we're not going to become a physics class. Don't worry. Okay, so this is not a bad little thing to look at and have sitting next to you as you do your homework, right? In fact, that's basically generally what I give you these worksheets for. They're not just one and done things. If I were you, I would have a lot of these worksheets sitting next to me as I'm doing homework. Of course, why not? You can't do that during a test, but you sure as all hell can do that during homework. Why not? All right, so let's come back to this. All right, so where was I? Oh, wait, somebody's chatting at me. I'm sorry. I missed that. Okay. What was I doing? Oh, yeah, we're looking at this thing. All right, so we know that the amplitude is 3. Now, period. Somebody remind me, what's the period, normal period for a sine function?
2 pi.
Okay, you kind of cut out there a little bit. 2 pi?
Yes,
And what am I going to divide that by?
by k.
In this case, what's k?
It would be 5.
No, careful. The period is the
It's 8.
It's 8. So it's the number that is directly multiplying the x, because the period is in the x direction. Like the 5 can be moved over and directly affects the y. So that's going to be the up and down motion, right? That's going to be moving the whole thing up or moving the whole thing down. That's what the 5 does. So the period will be 2 pi divided by 8. So period is pi over 4. What's the phase shift? Which is another way of saying the horizontal shift. Does it move
Negative
left 3 or what? So say it again.
-4 to the left 4.
It goes left 4. I love it. How do we know that? Because there's a +4 on the x, and since it's on the variable, it's going to do the opposite. Remember that? This is the way transformations work. So the phase shift will be left 4. Now look, how can I tell that number 15 is going to be disgusting? The period is in terms of pi, but the phase shift is not. Do you guys understand that? That is a horrible, horrible combination. I don't know do you guys understand that? It's much easier if these are both in terms of pi or if they're both just numbers. But the minute you have one of them is in pi and one of them isn't, oh my God, that does not, what's 4 minus pi? Somebody just tell me what 4 minus pi is. I have no idea. Well, I do, but I don't know exactly what it is. Right? Maybe? No? So, to repeat what I said earlier, if you don't graph 15, you're okay. But I just want you to do, look, I've already done most of the work for you. Why did I do that? Because I can't stop. I don't know. So really, you just have one more shift to list on number 15, and you can try to graph it if you want to for just to see if you can. All right. Something else I want to talk about is down here. These guys, I want to adjust their instructions. You don't have to start at x equals 0. Right. So if you guys look at this, it says start at x equals 0. Screw them. You start wherever the shift takes you. Does that make any sense? Remember when I did the begin and the end? We'll do some more examples of this. You start wherever the shift takes you. So that's fine, right? So say again.
I'm just checking. So it says graph 1 full period of each function, but I think the answer has three periods.
Oh, I don't care. If they have a mistake in the answer key, I don't care. Well, all that matters is that you do. If you graph more than one period, then you have graphed one full period, right?
Yeah.
Yeah, so they just chose to do more. Oh well, they
Okay.
can do more. Yeah. Let me see. I'm sorry. Somebody elaborate on what now? Sorry. Who is that? I lost it. Okay, here it is. Start where the shift. Oh, I see what you mean. So like number 19. What's the phase shift on number 19? What's the phase shift?
Negative pi over 3.
So left pi over 3. So when you go to graph, and there's other stuff going on too. What's this going to do? We haven't really done one of these, but this is not that big of a deal. What does that do?
Reflection.
Reflection around what? X-axis. Good. I like it. All right. And then, of course, this is just going to shift it up 1. But left pi over 3. So I can start everything at negative pi over 3. I don't have to start at 0. Screw them. Okay. That makes it unnecessarily difficult to start at 0. That doesn't make any sense to me. So you start whatever makes sense for the shifts that you see. Does that make sense now? What I need from you? Maybe? No? I haven't made sense at all today? All right. You never make sense, Jeff. So why would I expect you to start now? Okay, I understand. Can you do 18 or 19? I don't know. Let's see. Oh, all right. We basically have started number 19. Let's just keep going with it. Here, let me erase some of this stuff here. All right, so the phase shift, left pi over 3. What's the amplitude? Be careful now. What's the amplitude?
Negative 1.
Nope.
1.
1.
2.
It's 1.
Oh,
Yeah. So A is negative 1, but the amplitude is the absolute value of negative 1. You wouldn't say, I'm not sure how to say this. Just because the ocean goes down a foot, you wouldn't say it's now negative 1 foot. It's just down, it's 1 foot less than it used to be or something. So the amplitude is a positive number. It's just the distance it gets away from its midline. Does that make sense? So I would never say it gets negative distance away. Right? Okay, maybe. All right. It's a reflection though. We'll put that down here. There's a reflection across the x-axis. I like it. Everybody with me so far? So we got a phase shift that we say inside. We have an amplitude of 1. We have a reflection because it's got a negative sign. What is this doing?
Go up.
Yeah, and then I go up 1. And real quick, what's the period going to be?
2 pi.
Yeah, because what's K?
1.
There's a 1 in front of the T, so the period stays 2 pi. Okay. All right, let me stop for a minute. This is really gross, Jeff. Let me see. Let me do this. I'm going to consolidate this over here. So period equals 2 pi. Amplitude equals 1. Reflect x-axis up 1. There we go. Oops. I forgot my left pi over 3. Left pi over 3, up 1. There we go. That's a nice consolidation of what is happening. Okay. Now when you go to graph it, and again, if you want to, all right, you guys have got to do this enough to make this your own. What I'm about to remind you of is unnecessary, truly, but it's a nice way to do this when you're trying to learn how to do this. So I've got a begin and an end. So I take what's inside the trig function and set it equal to 0, which is where I normally start, and set it equal to 2 pi, which is where I normally end. And if I solve, I'll figure out where I now will start And 2 pi minus pi over 3 is 6 pi over 3 minus pi over 3 is 5 pi, and where I will now end. All right, let me stop for a minute. Are you guys remembering that? The begin and end thing? That actually is unnecessary. You actually do not have to do this, but it's kind of nice to have as a reminder of where things should start and where things should end. So I'm going to start at negative pi over 3. What's my step size going to be? What are my, all right, so what are my normal points? What are my points that I use in between these two? There's 4 points. There's 5, I guess, if you count 0. What are these anchor points? You got to know these. What are these anchor points? What's right in the middle of 0 and 2 pi? What's right here?
Pi.
Pi, holy shit. That's right in the middle of 0 and 2 pi. What's right in the middle of 0 and pi?
Pi over
Half a
3.
pi,
Half a pi. I love it. Half a pi.
pi over 2.
And 3 pi over 2 for over there. I like it. So no pi, half a pi, 1 pi, 3 halves of a pi, and 2 pies. All right. Those are my normal locations. And cosine, of course, starts high, then goes to 0, goes low, goes to 0, goes high. So that's what cosine normally does. All right, so that's like my base graph. And I know we just learned it. I understand that. But so you can kind of have a graph sitting next to you. So remember what the hell it normally does. So now at pi over 3, so when cosine begins, it starts off at its highest point, right? But what's going to happen now? Let me do this for myself. So I'm going to do this in steps. I'm going to do all these, and then I'll do this last. I really want you guys with me. All right, let me see. You got to be honest with me. You can privately chat me right now. Is everybody cool with this little quick thing I did down here? This is just the normal cosine. Okay, this is what cosine normally does. It likes it at 0. It hates it at pi over 2. It likes it at pi negative wise. It hates it at 3 pi over 2 because it's at the y-axis then. And then it's at the x-axis again. It's all happy. So that's what cosine does. So it would normally be right here where it starts. Where does it begin? It begins at its highest point. But of course, what's that negative do to me?
Flip.
Flips it. So I'm going to be right there then. Oh, let me do this in a different color. Up. Oh shit. I'm sorry, little dude. No, little dude. Oh yeah, and I forgot my step size. Hold on. All right, let me draw on this one little thing and then we'll talk about step size. All right. How big is each step I'm going to take? So normally every step is pi over 2, and this one, the period didn't change, right? So it's still going to be pi over 2. So now watch what I can do. Now come on, you gotta pay attention. This is not too crazy. Is everybody cool that the step is normally pi over 2? You guys see that? Nothing amazing there. Ooh, that's amazing, Jeff. What do I currently have? Where am I starting? I'm starting at negative pi over 3. So what I can do for myself is I can make this negative 2 pi over 6. That's still the same thing, right? And then I'm stepping by 3 pi over 6. So if I make my denominators agree, that makes all of this much easier. So if I take one step from where I am now, from negative 2 pi over 6, so where do I go?
Pi over 6.
That's right, Rio. Now, for the rest of the problem, I know Rio gets this. So I'm okay. You don't say any more, Rio. I know you got it. I want someone else to help me. And I think who else has helped me already? All right. So everybody get that? I'm at negative 2 pi over 6. If I take a step at 3 pi over 6, now I'm at positive pi over 6. Where do I go from here? Take one more step. Where am I now? Somebody else. I'm at pi over 6. If I take one more step, where am I? Every step is 3 pi over 6. I'm at pi over 6. Where do I go next?
4 pi over 6.
4 pi over 6. So what am I doing right now? I am doing what I did right here really easily because I started at 0. I'm just doing it again starting here. One more step.
7 pi over 6.
7 pi over 6. Get in there. And I'm supposed to end at 5 pi over 3, right? So if I take one more step, where am I going to be at?
11 pi over 6.
No, careful. Right? Add 3 pi over 6. Isn't 10 pi over 6 equal to 5 pi over 3? Isn't that nice to know you've ended where you were supposed to end? Do you guys understand what I'm trying to tell you? All right, maybe. So now let me come back to my
I
other
have a
color.
question.
Yes.
So when you graph this graph, do you have to show all the steps? Like how you, or you just have to, how do you call these scales?
You have to show the scale, yeah.
You don't have to show the work.
What do you mean? So if I see this and I see this, I understand what you've done. So
Okay, yeah.
yeah, the idea of showing work is show me your thought process, however you
Huh.
can. And so this and this together tell me that you know what the hell you're doing.
What is STG?
Where am I looking? Sorry.
What is STG?
Step. Sorry.
Thank
Yeah. So the step size. Yeah. Yeah. All right. So now it starts low. It goes to 0. Goes high. Goes to 0. Goes low. So that is before I've done the last thing, right? So the last thing you almost always do is the vertical shift. So the last thing I have to do is go up 1. So once I do that, I'm done. So now this is going to be there. 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 This is going to go up there. And then I've got my, whoa, shit. Make that big. Whoa. Okay. And how can you check this? Well, you can pick a point. You can plug 7 pi over 6 in and see if your output is 1. Do you understand what I'm saying? So you can check your work. If you plug a 7 pi over 6 in here, you can make sure that the output is 1. That's what it's supposed to be. Okay. Why does it make sense? What is the range of this now? Somebody else who I have not heard anything from. Now's your time to shine. The green graph, which is the graph of number 19. What is its range? What's the range of my function, of the green function here? What's the range? Come on, you could do it. What does range mean? Which variable does the range correspond to? Oh man, I've got chats. Oh, okay, somebody had to leave. Oh, I'm sorry, Faye. All right, I'm sorry, I didn't mean to call you out. And then somebody else, okay, 2 pi. Oh, that's from earlier. Okay, I don't know why it's not showing me the chat. It's not doing a good job of telling me when somebody chats at me. So the step size, all right. So real quick, I'll give you guys a minute to think about what the hell I just asked. Oh shit. So step size down here, I really want this to make nothing but sense. Hold on, let me recreate this. So I've got this. So here's my normal steps is, why are my steps pi over 2 big? Because how far do I have to go to pi? How many steps am I taking? 4. So how do I always figure out my step size for cosine or sine? I take the period divided by 4. I just break how long it's going to take me to go through a cycle I break it into 4 parts. Does that make sense? Person that asked that question? Are you chatting at me? Yes, and it's still not showing me the chat. Dang it. Oh, all right. Somebody, you got that backwards, right, Menda? Because you would never tell me that it's from 2 to 0. You mean from 0 to 2. So why does that make sense that it's now from 0 to 2, the range? What was it to begin with? What's the range of cosine normally? Uh-oh. What's the range of cosine normally? Cosine goes between what and what? What's the
Minus
highest?
1,
What's the lowest?
-1 to 1.
-1 to 1. And if I shift that up by 1, so if it normally goes from -1 to 1, and if I shift that up by 1, of course it's going to go from 0 to 2 now. I really want that just to make sense. If it goes from -1 to 1 normally, and I move it up 1, of course it's going to go from 0 to 2. Okay. All right. So let's do this. Let's do this in a little more organized fashion. I've got up on Canvas, I've got this bad boy. I also want to try something new with you guys tonight. Let's see, is this the one? Yes. Let's unlock this bad boy here. Stop saying bad boy, Jeff. That's weird. I know. Hold on. Where did you go? All right, so if you go to Canvas right now, you should see under Unit 8. I'll show you. You will see this. Let me become a student so it looks the same as it would for you. Oh, wait a minute. Okay, sorry. Unit 8. Trig graph practice right there. This sheet right here. Let's do this. There's another one on the other side I'm not too worried about yet. Let's just do this one. So you guys, right now, go get this from Canvas. And I was very nice up here. I'm stepping you through everything. Grab that bit, that sheet, and do it. Give it a try. Right, now's the time to make mistakes, get them all out of your system. I'm never going to see this ever unless you hold it up to your camera or something. So just try it, right? I'm going to try to, let's see if I can find this. I can open this a different way. What will this be called? Do. I remember. Drive me crazy. Here it is. Sweet. Is this the one? No, it's different. Why is it different? Why are you different? Crazy. Here it is. This has got to be it. Yes. Do. All right, where'd you go? Okay, this is better. All right, hopefully you guys are trying this. So just to remind you guys, who knows the first thing they should do with this to help them with a part of this? What's the first thing I should do that I didn't do for you because I'm evil?
After?
Yes. So then you can more easily see what the phase shift is. Can somebody else tell me what you get when you take a 1/2 out? X minus what? If I divide the top by 1, I get pi. So if I divide the bottom by, come on, what do you get? Pi over
4.
4, thank you. All right, so now it should be easier to tell what the phase shift is. All right, so go ahead, try to do these. If you have no idea how to do these, you need to start asking questions. I really hope I'm not coming off as opposed to students asking questions, because I am the exact opposite of that. Oh, I tell you to do that. Look how nice I am. Holy shit. This is past Jeff. Past Jeff was really nice. He was a nice guy. What happened to that guy? I don't know. So real quick, what's K?
2.
No?
1/2.
1/2. Like K is the thing that affects the X. So that's the 1/2. The amplitude is
2.
2. All right, now somebody else tell me what do you get for the period? Anybody? Hello? You guys out there?
4 pi.
Thank you. 2 pi divided by 1/2 is 2 pi times the reciprocal is 4 pi. So the period is 4 pi. I don't talk about steps in here, but I don't know why I don't do that. How big are the steps I'm going to take? Well, if I take how big the period is, cut it in 4s, because that's how I normally go. There's 4 steps. Every step should be pi big. Now, somebody else. What's the phase shift? Shift by how much?
Right. Pi over 8.
Huh? No. Careful. Nope.
Pi over 4
That's right. To the
to the
left or to the right, or to the left or to the
oh,
right?
to the right.
Right. Exactly. Because it is the opposite of what it looks like. All right. Now, the more you do this, the less you might have to do the beginning end thing, but this is not a bad little thing to do. I'll do it very quickly. What I would do is, so if you add pi over 8 over, I can then just multiply both sides by 2. You get pi over 4. That makes sense because of what we just said here, right? So you see why it's not necessary. I already knew I was going to start at pi over 4 because I know I'm shifting pi over 4 to the right, but it's still nice. And then this one I would multiply by 2 first. That makes things a little bit easier. And then I add pi over 4 to 4 pi. 4 pi is 16 pi over 4, so it's 17 pi over 4. How far apart are these two? Pi over 4 to 17 pi over 4. How far is that?
17.
No. What? How far apart are pi over 4 and 7? How far apart are 1 and 7? You would do 7 minus 1. It's 6 apart. So how far apart are pi over 4 and 17 pi over 4?
It would be just 16 pi over 4,
Which is?
which is 4 pi.
Which is nice because that's what it's supposed to be, right? The period is supposed to be 4 pi. Do you see how there's checks and balances here? So you can constantly make sure you're looking at things correctly. Okay, maybe. So how the hell are we going to do this? All right. So I got to start at pi over 4. How big is the steps? The steps are pi, right? So I'm going to start at, so watch what I'm going to do. I'm not going to use pi. I'm going to use 4 pi over 4 because I've got an over 4 for where I'm starting. Do you guys understand what I'm trying to help you with here? Okay. So if I start at pi over 4, and every step is 4 pi over 4 big, where do I go next? If I start at pi over 4, and every step I take is 4 pi over 4, where do I end up if I take one step up?
5 pi over 4.
5 pi over 4, okay. All right, so you guys you accept that some things are easy, right? I know it seems like the entire thing is craziness, but some things are nice. They're not bad. They're not evil. So what's the next thing? Somebody else tell me what's the next step?
9 pi over 4.
Shit, right? 9 pi over 4, I like it. And then
13 pi over 4.
13 pi over 4. And then
17 pi over 4.
become a pi. 17 pi over 4. I like it. And there's my 17 pi over 4, right? Why do I have so many steps? That's weird. 1. Oh, okay. I'm looking at it wrong. Okay, I'm with you. All right. So I've got cosine. The amplitude is 2. I really want this you have to, this is what you really have to get right now. And I don't know if you guys understand, this is really the whole idea of all the function drawing we've ever done. What is the base? Oh shit, there's a bunch of chats. I'm sorry guys. The chats I'm completely missing. What does the base function look like? You've heard me say that so much. We have to, pre-calculus is graphing hell. I think I told you that. So a huge part of it is what do functions look like normally before any weird shit has happened to them? What do they look like? So cosine, what does it look like? Does it start at 0? Does it start at 1? Does it start at -1? What's it look like normally? Cosine. What's cosine of 0? What's cosine of 0?
It's just start with 1.
Yeah. So cosine starts maximal. Cosine starts at its highest point. I don't know. Am I being punked? Did you guys all get together and say, don't say anything to him? See how long it is until he goes completely insane. All right, starts high, goes through 0 at pi over 2 because it really hates it at pi over 2. Poor little dude. Becomes maximum negative at pi. Goes through 0 again. And then goes high. So that's what cosine normally does. Let's see, there's 4 steps. 1, 2, get out of there, Jeff. 1, 2, 3, 4. So all of that's still going to happen. It's just going to happen starting at pi over 4 instead of starting at 0. It's going to start at pi over 4. So at pi over 4 is where it starts. It hasn't been reflected or anything. So it's going to start at the highest point because that's what it does. Then it's going to go through 0. It's going to go to its lowest point. It's going to go through 0 again. I kind of missed that, didn't I? And then it's going to go to its highest point. So it's going to go. All right, that's horrible, but you get the idea. This is really bad, but oh well, make that big. Poor little dude. All right. Oh, what is happening? That's interesting. Sorry, I got a message from Zoom out of nowhere. All right. Do you guys start to understand what I'm trying to tell you? So it's all about, what does it normally do? It wants to do all that same stuff, but now it's going to have to live between these two things. I really want this to make sense. All right, and of course it would keep going in both directions, repeating this forever. Okay. Now, let's see if I can push. Let me see. What do I want to do? Let's do this. Let's do this before I talk about this other thing. I'm going to stop sharing. Is everybody ready? Have you got what you want from this? More than you wanted? Okay. Let me see if this works. I want to try to use this. You guys are going to be my guinea pig. Does that sound exciting? All right. So what I want you to do, if you can't trust me, I don't know who you can trust. Please, if you're able to, click that link I just put in. I built something in Desmos. I didn't really build it. I stole it from somebody. Is everybody clicking that link? Can you see what you see? What do you see when you click that link?
Graph.
It's like a wave line.
Hold on. Oh, but now, are you talking about? All right, let me make sure I'm with you. So do you see this? All right, this is what I was worried about. I was hoping it would let you just. I don't know. Have you guys? Has anybody created an account with Desmos? Maybe we'll try to do this some other time. Maybe I should ask you to. You can either sign in with Google or you can create an account through Desmos. It's a free thing. So let me do this for tonight. All right, hold on. Let me do this. So if you want to sign up through Desmos, maybe I'll try to do this in the future. I didn't even realize that it had this capability. So for tonight, I'll just kind of go with it. Oh, look, there's a few people signed in. I see you guys. All right, let me ask you guys, those people who have signed in, did you already have a Desmos account or did you just now create one?
I
Use Google?
yes.
Okay.
I sign in with Google as well.
All right. So go ahead. Everybody should be able to then. Let's do it. Should be relatively simple to do. All right, here comes some more people. I appreciate this. Y'all like, please, dear God, anything different besides just this guy talking forever? I understand. All right. What's it look like from your side? Let me see. I've never actually. I'm going to sign in like a student. Let's see what I see. Oh, cool. You see an assignment thing, right? Do you understand what it's asking you to do? So this is such a neat thing. This is where you get to play a little bit. So you should be seeing this, right? After you sign in. So look what happens. Obviously, what does A control?
The amplitude?
amplitude. So obviously it's just going to make it right. Now watch what happens when I go negative. It's reflecting. Watch what happens when I make it 0. That kind of makes, if I make it 0, that just kills the whole thing, right? All right, so what it wants you to do is make it so it fits perfectly between these blue lines. Go ahead. Let me see, I should be able to, as the teacher, let me see, I should be able to see everybody's work. Let me see what I can see. Ooh, look at that. This kicks ass. I can see people working. Oh, that's so neat. All right. Is there like a share? Let me see. No, not yet. Okay. So let me see.
Oh, I just did it. I think A it's gonna be 2
Don't say
and
it.
B.
Don't say it. Do it.
Oh, okay.
All right, let me see if everybody's got it yet. Hold on. Let me take a look here. All right, looks like, yeah. All right, looks like most of you guys got it. There's one person that the graph isn't going anywhere. That's got me concerned. Somebody's already moved on to other things, it looks like. No, you're still on the first one. You just had some neat stuff happening. All right. I'm sorry. Let's see. All right, let me show you my student screen here. Let me go back and let me mess this up a little bit. All right, so watch this. Here's what's happening. So where's the midline? So most of you guys got this, but let me just make sure you guys can look at this the right way. I don't know if anybody was just kind of playing until it worked. Where's the midline supposed to be now to make it fit between these two lines? Where's the midline?
3.
3. The midline is normally at 0, correct? Right? For a normal trig function, the midline is at 0. Are you with me? That's the line that it kind of oscillates around. So if I want it to now be at 3, what should I make b equal? I need to move the whole thing up by 3. Now, it's not fitting snugly, is it? It's not fitting snug in there, so I have to change my amplitude to 2, which makes sense because now it's going to go up 2 from 3 and down 2 from 3. So it's going to go to 5 and to 1. Does that make sense? This kind of thing I love because this takes you away from the technical details and more to just playing around. Playing around. So the next thing I ask you is, so we already know what this is. We already figured this out. Right? A is, I already forgot it, 2, and B was 3. Right? We share with the class. Oh, look. Now, this is not this person's name, so I can anonymize people's names so that people cannot see you. Oh, there we go. See, more people are answering. There we go. These people, by the way, the names that it gives you anonymously, like me, I think I'm Moon Dutchin. Am I? So the names are actual mathematicians. Moon Dutchin is in Medford, Massachusetts. That's neat. There's more people. Okay, I like it. Now, if you go to the next thing, it's a similar thing, right? So you got to get it to fit in between those. This is a little bit weirder. All right, let me stop sharing. Is that better? Does it make sense about, okay. So this is just sort of allowing you to play a little bit with what's going on. All right, let me see what I can do here. Let me see if anybody's on 3. Okay, I got 5 people on the third one now. On the third, what do you call it? Somebody's on the 4th one. Cool your jets down there. What's going on? Overachiever. Here we go. I like it. Somebody got to be Leonard Euler. Euler is the guy who did too much. It's like, leave something for somebody else, Euler. All right, you guys are getting the idea. I like it. Let me see now. Let's do one more thing up here because I don't want to stay on this forever. I need to make this a little bit better in general. I want to let's do this. Can we shoot, where was the one? Here it is. Can you guys go to the 10th? Go to the 10th what do you call it? The 10th thing. The 10th option. I don't know what the shit. Here, hold on. I don't know what the right name is for this thing. Here, the 10th out of 20, right? Just go to the 10th one. Okay, is everybody with me? Everybody go to the 10th one. I'm gonna go see if there's anybody not on the 10th one. All right. Oh man, Euler, I was just singing your praises and oh, there you are. Now you're on the 10th one. Everybody's on the 10th one. Good, thank you. All right, sweet. See, this kicks ass. This helps me out. This is what I've been missing. Because I'm sitting here like, I have no idea if people are actually there even. All right, so now I can see you guys are trying this out. Okay. Everybody's here, but not everybody's trying this out. So what you want to do, you want to kind of attack this. So think about it, 4 to 20. It's supposed to go from 4 degrees to 20 degrees, right? So where should the midline be? And what letter does the midline help you figure out? Do you understand what the question is? Where should the midline be if it goes from 4 to 20? Somebody. Where should the midline be if it goes from 4 to 20?
10.
No. 10
11.
is 6 from 4, but 10 from 20. Say again?
11.
Closer, 12. So all you got to do to figure out the middle of two numbers is add them and divide by 2, right? Just take the average and you can find the middle of any two numbers. So 4 and 20 is 24, divided by 2 is 12. 12 is 8 from 4 and it's 8 from 20. So that's the midline. So what letter does that tell you the value for?
B.
B, I love it. So you know B has got to be 12. That's what you start with. Then the amplitude, you can actually just play around with it, or you can figure it out mathematically what it's got to be. We already figured out what the amplitude's got to be. What did I just say? 12 is how far away from 4 and 20? How far away is 12 from 4? 8.
8.
Which means the amplitude has to be 8. Does that make sense? Do you guys see what I'm saying? So this kind of thing, sorry, second.
I have -8. I don't know if that's right.
Oh, let me see, what's it say? Supposed to vary from 4 degrees at midnight. Yeah, I got to actually read what it's supposed to do. Yeah, so why, you're right. Why has it got to be -8? Because otherwise, if it's 8, what is it starting at midnight? And what's midnight on a military clock? Because this is hours since midnight, so it's more like military time. Where is midnight on this graph? Where is midnight? Here, let me show you. All right, so Faye's got a really good point. I wasn't paying as much attention as I should have. Where's midnight on this graph? What's happening? What does X stand for? What does X mean?
Oh, sorry. Midnight of hours. Hours since midnight.
All right, so where is midnight? If X is hours since midnight, is 5 midnight? Where is midnight?
12 hours.
No. X is hours since midnight.
24.
So how many? Huh? No.
24.
Okay, 24 sort of. I get you. Yeah, 24 would work. Sure. But better would be 0, right? Am I currently doing what it says to do? 4 degrees at midnight. Am I at 4 degrees at midnight? Midnight is at 0, right? Because 0 hours since midnight is midnight. Is that cool? Am I at 4 degrees? No. So if I make it -8, I start at the lowest part. Now I'm at 4 degrees at midnight, and I'm at 20 degrees at midday, which is noon, 10, 11, 12. There's midday right there. Is you guys with me? So that's 1 a.m., 2 a.m., 3 a.m., 4 a.m., so forth. All right. Okay. All right. Okay. All right. So you guys can play around with that for a while if you want to. I want to do one more thing, which was what, Jeff? What did you want to do? I've totally forgotten. Oh, yeah, that's right. Let me do this. Yeah, this will be interesting. Let's do this. All right, let's see if I can get your attention back from that, because that is kind of neat just to move those sliders around and see what it does. It's always a neat thing. All right, now watch. Clear. Okay, let me just do a cosine function, and I have to make sure, let's make myself in radians. And watch what I could do. I could do zoom trig. Let's see what that does for me. Oh shit, I got something, hold on. I got something left over from my stats class that's freaking this poor thing out. Come on. All right, sorry. Zoom 7. All right, there we go. So there's cosine function, right? How does secant compare to cosine? So this is y equals cosine. How does secant compare to cosine?
Upside down.
Okay, I'll accept it. 1 over cosine. So somebody help me out. If I'm going to graph the secant function, if I was going to graph the secant function, I just have to do 1 divided by cosine. So for example, what's the value of cosine right here? What's cosine right here?
1.
1. And what's 1 divided by 1?
1.
Holy shit. Now, is everybody with me? I'm going to graph secant. What's happening to cosine as I move this way? Cosine is getting smaller, correct? So what should happen to secant? What's 1 divided by 0.9, 0.8, 0.7, 0.6? What's that doing? So about right here, it's 0.7. 1 divided by 0.7 is about 1.4 or something. So I'm going to be up here somewhere. Right here is about 0.5. So that's about 2. 1 divided by 0.5 is 2. What happens right there? What's cosine right here?
Asymptotes.
Yeah, it's going to be an asymptote. Cosine right here is 0. So what's 1 divided by something approaching 0? That's going to be where I have an asymptote. So my secant function is going to look like this. And there's going to be another asymptote here. How many asymptotes are there going to be?
A lot.
There's going to be an infinite number, exactly.
I have a question.
Yes.
Do you have a secant?
We're going to do it right now. You ready? I know what you're saying. All right, I'm going to clear this away and we're going to graph secant. So what Rio is asking is, does anyone see a secant button? Is this the secant button right here? Hell no. What does this represent?
Inverse.
Good. That's the inverse, which is not the same thing as reciprocal. So how the shit am I going to tell it to graph secant? Well, I'm just going to do 1 divided by cosine. Of course, right? That's why they don't build secant and all that stuff in, because it's just 1 divided by what they've already put. Why would they want to shove 3 more buttons in here? Is everybody with me out there? You guys all right out there? Let's see if this does what I said it should. Oh, look at that. It looks like what I was drawing, just good. Right? And here's my asymptotes that make sense because secant is 1 divided by cosine. So wherever cosine is 0, there should be an asymptote, correct? You guys see what's happening? Do you guys understand what's happening? No? All right. You're just not going to talk to me. Fine. Okay, so if I look back at this sheet, I'm almost certain most of you guys are still playing around with that. Let's see. Oh, okay, maybe not. All right, I don't know what you guys are doing. If you look back at this sheet up on Canvas, where'd you go? Here it is. Here. So if I wanted to graph cosecant, I would first pretend as if this says what? What is cosecant related to?
Sine.
Sine. Pretend like a sine. Do everything as if it was sine. Do all this work as if it was sine. But when I go to graph it, I'm going to put a dotted line. Let me see, what time is it? Nah, I'm not going to do this at the end of class here. I would graph everything like it was a sine function. So I graph a sine function. Oops, shit. I just didn't do what I said you should do. All right. Graph it like it's a sine function. Wee-ha, wee-ha, wee-ha. And then I'm going to put little cups. Cup up, cup down, cup down with my little asymptotes. I have no idea if you guys are with me. It's really beautiful to graph the inverse trig, like the cosecant and the secant. You do a dotted line, sine or cosine, and then you just have to graph the little kind of opposite little parabola looking dudes. It's really, 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 really nice. So that's what I mean up here when I say we first graph sine or cosine and then plop our u's. So that was the u stuff I was making on top and bottom of the sine and cosine. It's really almost too nice to believe. Okay, I think that's enough for today. We've done quite a bit. So we really just have, we need to do some cosecant and secant examples. We need to talk about tangent and cotangent, and we need to talk about inverse trig functions. And then that would finish up chapter 8. So we'll do a good chunk of that tomorrow. The quiz should be open now, I think. So you could actually go start on the quiz immediately if you wanted to. Yeah, otherwise you're free to go. Let me know if you have any questions. Otherwise, I'll see you guys tomorrow.
Thank you.
Yes, Professor, I have a question.
Yes.
I have a question about chapter 7, section 1, number 55.
All right, 7-1. Let me see.
Yeah, no, get there.
55, okay. Hello?
I can hear you.
What? Hello? Can you hear me? Yes? Oh.
I can.
Okay. So, what does coterminal mean?
It's like, I know it, but I can't explain it.
So, real quick, little example. Let's see, what's a nice easy one? So pi over 2 is coterminal with 5 pi over 2. Because they
Right.
both end up at the same place, right? How far
Yeah, got
apart are pi over 2 and 5 pi over 2? They are 4 pi over 2. They are 2 pi apart, which is one way to do a coterminal angle. So this one doesn't, what's 10 pi over 3? Let's see, what's 2 pi? What is that over 3?
60.
60. What do you mean? No. What? No.
Oh, 360.
No. Stop with the degrees. I don't care about degrees. 2 pi over 1 equals what over 3?
6 pi.
Yes, 6 pi. So how much past that is 10 pi over 3? Oops, it's going to be over here. How much past 6 pi over 3 is 10 pi over 3? So I went
20.
around 6 pi over 3. Sorry?
20.
20. No. How much do I go from 6 pi over 3 to 10 pi over 3? How much do you add?
4 pi
4
on the
pi.
top.
There you go. That's what the answer is. So it's kind of like if I start with 10 pi over 3, you can subtract a rotation. Because they went around all the way around and then stopped. So why do this 2 pi rotation? Just subtract that out. If you just go 4 pi over 3, you go to the same place. That's what that means. How do we get to the same place? With an angle between 0 and 2 pi. So I can take that angle and I can subtract a full rotation off.
Oh, we got it.
Yeah, so it's like if I had 380 degrees, a coterminal angle is 20 degrees. Yeah.
I understand.
You might have to subtract more than one rotation, right? Like maybe this one is going to take subtracting a few rotations off. Yeah. Okay. Is that better?
So 1 full rotation is 2 pi, right?
Yes. Cool. 2 pi
Yeah, I
radius.
understand.
I like it.
Thanks.
You're welcome.
Bye.
You. Everybody else okay? All right. I'll see you guys later.